Welcome again to my channel Talking Physics with Piyas Sarkar. I hope you are all well and पढ़ाई लिखाई सब अच्छी से चल रहे हैं। तो आज हम जो इस टॉपिक में डिस्कशन करेंगे वो है द थर्ड पार्ट ऑफ फोटोइलेक्ट्रिक इफेक्ट, दैट इज ड्यूअल नेचर ऑफ रेडिएशन एंड मैटर और डी ब्रोगली हाइपोथेसिस एंड कुछ बहुत इम्पॉर्टेंट सवाल जो जॉइंट और नीट के लिए बहुत ही इम्पॉर्टेंट है, तो उसको हम देखेंगे। सो प्लीज कीप watching, don't skip the video or leave the video. We will gain some definite knowledge from it. Okay, so without wasting time, we are go for the topic dual nature of radiation. Dual nature of radiation. So dual nature of radiation, as we know from the optics, wave optics, that a wave has two properties. Wave can shows two properties. One is particle and one is wave properties. One is particle behavior and one is wave behavior or wave properties. As we know that light shows two type of behavior. Particle behavior, in some experiment a wave shows particle behavior. In which experiment? Photoelectric effect. Photoelectric effect, Compton effect, and wave behavior, interference, diffraction, polarization. But keep in mind in one thing, that two properties cannot be display at a single experiment. ऐसा कोई एक्सपेरिमेंट नहीं है जिसमें ये दोनों प्रॉपर्टी ही साइमल्टेनियसली नजर आए. सो पार्टिकल बिहेवियर ऑफ लाइट is shown in some experiment and wave behavior is shown in some experiment. Now we can go with the dual nature of matter. क्या पार्टिकल भी वेव प्रॉपर्टीज दिखाती है और नहीं? ड्यूअल नेचर ऑफ मैटर. In 1924, the scientist de Broglie, pronounced it as de Broglie. The pronunciation is de Broglie. It suggested that yes, a matter can also shows wave property. This is known as de Broglie hypothesis. We can write as de Broglie, but we can pronounce as de Broglie wavelength, de Broglie hypothesis. So he says that yes, when a matter, when a material particle is in motion, it shows wave like properties. When a material particle is in motion, it shows wave like properties. This theory is known as de Broglie hypothesis. So what is the significance of it, or what is the meaning of it? Electron, proton, neutron, when they are in motion, they behave as wave. and also the waves associated with is known as de Broglie wavelength. De Broglie wavelength. The waves associated with is known as de Broglie wavelength. Suppose an electron or any material particle has mass m and moving with velocity v, then what is its momentum? mv. Okay. Now, according to Einstein mass energy relation, the energy is given by, you know the relation, E equal to mc square. The energy is given by equal to mc square. This is the material properties of electron. In this equation, electron is considered as particle, not wave. But again, the energy associated with radiation, any radiation, we know E equal to h nu. So this equation is 2. This is particle properties of any material particle, okay, not only electron but any material particle, and the energy associated with radiation is, this is wave properties. So if we equate these two equations, what we can get? What we can get? Equal to mc square and equal to h nu. That is, we can say that h nu must be equal to mc square. And we know nu equal to c by lambda, c equal to nu lambda. So we can write as h c by lambda is equal to mc square. Therefore, what is the value of lambda? Lambda equal to hc upon mc square. So we can get h by mc. We can write that momentum is mv, but a particle moving with velocity c, that is the speed of light in vacuum, is given by mc. So we can write as h by e. This equation is known as de Broglie hypothesis, and this lambda is called de Broglie wavelength. This is very important in quantum mechanics, in dual nature of particle, and obviously in atomic physics. Okay, so we have derived just the de Broglie wavelength equation. Now we can say some important things from this equation. What we can say? आप लोग से एक अनुरोध है कि कभी भी वीडियो को स्किप मत करना, क्योंकि एवरी मोमेंट इन माय लेक्चर, एवरी वीडियो हैज सम इम्पॉर्टेंट टॉपिक. हम लोग दिन में फेसबुक करते हैं, इंस्टाग्राम करते हैं और टाइम निकल जाता है, हमको पता ही नहीं चलता. लेकिन अगर वी कैन स्पेंड ओनली 20 मिनट इन लेक्चरिंग, इन listening videos, not only me but anybody, we can acquire some knowledge which can help us a lot in future. So please don't skip, watch my full video. Therefore, lambda equal to h by p. So what is the consequences? Lambda is inversely proportional to momentum. The de Broglie wavelength is inversely proportional to momentum as h is constant. H is known as Planck constant. We know you must memorize the value of Planck's constant in both CGS and SI. Lambda is inversely proportional to momentum. That is, for heavier particle, lambda will be small, and for larger particle, the lambda will be greater. Okay. If we consider a proton and electron, which is heavier? Obviously, proton. So, as proton is heavier, its de Broglie wavelength is small compared to electron, as electron is lighter than proton. Number 2, as V tends to 0, lambda tends to infinite. We can write P equal to lambda equal to h by mv. If V tends to 0, lambda tends to infinity, which has no physical significance. That means material particle, which is known as material particle is rest, does not display or shows wave properties. Only material particle in motion shows wave properties. Otherwise, it not shows wave properties. So, this is the main consequence or outcome of de Broglie hypothesis. Okay. So, one little question to you. As we know that the material particle in motion have de Broglie wavelength. So, why the de Broglie wavelength of football is not seen to us? Think it. I can tell you in my next video. Think it and reply. If you know, then reply in my comment section, and also subscribe my channel. So, this is known as number 3 is de Broglie wavelength is need not to be associated with charge. So, it is called matter wave. De Broglie wavelength may be in any particle, no matter it is charged or charge independent or charge dependent. Okay. Because photon which is massless and chargeless particle, we know has also de Broglie wavelength. But electromagnetic radiation is only charge dependent, associated with charge of accelerating particle. So, EM wave, that is electromagnetic wave, is differ from de Broglie wave as it is associated with, it is means electromagnetic wave associated with charge of accelerating particle. Charged with accelerating particle. Electromagnetic wave is differ from de Broglie wave as it is associated with charge of accelerating particle. This is the difference between electromagnetic wave and de Broglie wave. Okay. So we can know the de Broglie hypothesis. Acha, what is the difference between law and hypothesis? Why we cannot say de Broglie law? Hypothesis means which is not experimentally proved, but its use is vast. And on the base of hypothesis, many laws are written. So the Avogadro hypothesis is called Avogadro law or formula. But de Broglie hypothesis, many hypotheses in physics, de Broglie hypothesis and any other hypothesis. And also we know that the electron has de Broglie wavelength is measured by Davison-German experiment in electron microscope. Davison-German electron microscope experiment. The de Broglie wavelength of electron is measured in Davison and German, two scientists. The experiment name is electron diffraction experiment. Electron diffraction experiment. This is not in your syllabus. So we can go with the another topic, that is de Broglie wavelength of electron. De Broglie wavelength of electron. As electron is mass m, has mass m and velocity v, then its kinetic energy is half mv square. If the electron is gain velocity v, then its kinetic energy is half mv square, and the work done by the electric field, suppose this is an electric field, the work done by an electric field on the electron is its potential energy. So its potential energy must be EV. V is the accelerating potential. So we must equal to half mv square and EV. We must equal to, from energy conservation law, K equal to half mv square and must be equal to EV. Therefore, de Broglie wavelength of electron lambda is equal to h by mv, h by p, that is h by mv, h by mv. Now from this we can get the value of mv square equal to 2 ev, that is mv equal to, if we put m here, that is we can know that the kinetic energy is p square by twice m equal to ev, then p square equal to twice m ev, or p is root under twice m ev. So if we write this h by p, direct put the value of p, so we can get h under root twice m ev. This is the equation of de Broglie wavelength of electron, lambda equal to h by 2s m ev. If we put the value of h, that is 6.626 10 to the power minus 34 joule second by under root 2, mass of electron is 9.1 into 10 to the power minus 31, charge of electron is 1.6 into 10 to the power minus 19, and V. So we can get this value as 12.3 by root v एंगस्ट्रॉम। इस इक्वेशन को अपनी एक्सरसाइज बुक में नोट कर लीजिए, क्योंकि ये आपको बहुत जगह में इन शॉर्टकट प्रोसेस इन जॉइंट एंट्रेंस और नीट एग्जामिनेशन यू कैन पुट द वैल्यू ऑफ डायरेक्टली, है, नो नीड टू derivate the formula or put the value of formula, just memorize it, 12.3 by root v. In his experiment, Davison and Germer put a certain value of v so that the electron d Broglie wavelength is nearly equal to some nanometer. I cannot memorize that right now, the some nanometer. So for this contribution of d Broglie into physics, he got the Nobel Prize. So the electron d Broglie wavelength is 12.3 under root v angstrom. Now we can go with some application of photoelectric effect. Now we can go with some application of photoelectric effect. ये जो इंक है बहुत ज़्यादा चिपकू है और इसको पोंछने से भी ये स्पॉट छोड़ रही है। सो एप्लीकेशन ऑफ फोटोइलेक्ट्रिक इफेक्ट। Number 1, in cinematography, cinematography means obviously movie, film. There audio signal is transferred into electric signal and electric signal is transferred into light with the help of photovoltaic cell. The arrangement in which the light energy is converted into electric energy is known as photocells. The equipment in which radiation or light energy is converted into electrical energy is known as photocells. There are 3 types of photocells. One is photoemissive cell. Number 2 is photoconductive cells. And number 3 is photovoltaic cells. Voltaic, TAIC, photovoltaic cell. These 3 types of photo. The light incident and it converted into electrical energy, electron emission occurred. In cinematography, in fire alarm, when breakdown of fire occurred in some hospital or in office or in any place, the light disturbed the emission of ultraviolet on the system. Light way just disturb the incidence of ultraviolet radiation on the photovoltaic cell. As a result, the detector or the sensor has ring up. Similar configuration is shown in Broglie alarm or buzzer alarms. Buzzer alarm. In many cases, this is, and not only these 3, but many uses of photovoltaic cells in our modern daily life. Okay, so you have to memorize it, that the application of photoelectric effect and so on. So we can know from today's lecture that an electron or proton or any particle must be in motion, shows wave-like behavior. Just like light shows particle behavior in some experiment, then particle also shows wave-like behavior in some experiment. So, and obviously the derivation of Broglie hypothesis wavelength, Broglie wavelength, and the electron Broglie wavelength of electron is has to be derived by you in the exam as said. So, अच्छी से पढ़ाई करो, माँ बाप का नाम रोशन करो और देश का नाम रोशन करो। सामने ही आपका जो एचएस एग्जाम आ रहा है, जॉइंट आ रहा है, नीट आ रहा है, तो अगर आपको कोई भी टॉपिक्स ज़्यादा हार्ड लगता है तो प्लीज़ राइट मी इन माय कमेंट बॉक्स. I will discuss about the topic in my video. Okay, so let us do some numericals. Suppose the work function is given, we have to find out the cutoff wavelength. Suppose the work function of material, that is W0 is given as 4.125 eV. We set the cutoff wavelength lambda 0. How can we find this? So, as we know that when threshold frequency of incident radiation occurred, therefore we know W0 is must be equal to h nu 0. We can show it from the Einstein equation. So, the work function is given, the frequency is not given, but we can say that the cutoff wavelength, what is the cutoff wavelength or threshold wavelength? Cutoff wavelength. So, we can write nu 0 in terms of lambda 0, that is c by lambda 0. So, lambda 0 is equal to hc by w 0. Therefore, put the value of h, c and w 0, that is 6.626 into 10 to the power minus 34. It is in joule and 3 into 10 to the power 8 meter per second, and w 0 is given as ev, 4.125 eV. We know 1 eV equal to 1.6 into 10 to the power minus 19 joule. So, if we put this value, so we can get it in meter. Therefore, it is 3000 into 10 to the power minus 10 meter, that is 3000 angstrom. You can get the value of 3000 angstrom. Okay. Two basic formula in this equation is, आपको सिर्फ दो इक्वेशन अपने मन में मेमोराइज करना है. एक है आइंस्टाइन फोटो इलेक्ट्रिक इफेक्ट इक्वेशन, एक है जो आइंस्टाइन का फोटो इलेक्ट्रिक इक्वेशन है. क्या है वो? दैट हाफ mv मैक्स स्क्वायर इज इक्वल टू h nu minus w0 और h nu minus nu 0. और नंबर 2 is lambda is equal to h by p और h by root twice m ev. Number 3 is wavelength of electron, Broglie wavelength of electron, that is 12.3 by root v. Just note these three equations in your copy, which helps you a lot in doing any numericals. अगर आपको पूछा कि किसका दोनों का एक्सीलरेटिंग पोटेंशियल सेम है, then what will be the wavelength what will be the wavelength of proton and electron, which has much greater wavelength. So, whose mass is lighter will have greater Broglie wavelength. Okay, but in case of photon, this equation is not valid. We can say that the electron and photon has equal energies. The electron and photon have equal energies, which is greater. The electron proton have same wavelength, which has more energy, same wavelength. We can say that the electron and photon have same energies, same wavelength, which has greater energy. The electron and photon have same wavelength which has greater energy. As photon is a relativistic particle, its energy is given by E equal to p square c square plus m0 square c to the power 4, where m0 is rest mass. When photon is rest, its mass is m0. When photon is moving with a light velocity or velocity nearby right with a velocity v, then it is moving mass of photon. मूविंग मास, इसका मास चेंज हो जाता है, इक्वल टू m0 अपॉन 1 माइनस v स्क्वायर बाई c स्क्वायर. c is velocity of light, v is velocity of photon. So in this question they have same wavelength. Therefore, as lambda equal to h by p, so p equal to h upon lambda. Now P of E equal to h by lambda E, and P of P, that is photon, h by lambda P. If they have both same lambda, then their momentum will also be same. Momentum is written as, momentum will also be same. So PC, momentum is PC. PC is also same. The value of P square C square is same for both. But in photon, m0 is 0. But electron, for photon, rest mass m0 is 0, and for electron, mass m0 is greater than 0. So definitely electron has greater energy than photon, having same wavelength. Okay. Next, if the kinetic energy of a particle is increased by 16 times, if kinetic energy of a particle increased if kinetic energy of a particle increase 16 times than its previous value, find the change in, find the percentage change in भी बोल सकते हैं, find the percentage change in wavelength. So here we know that the wavelength is related with kinetic energy equal to h by under root twice m k. K is the kinetic energy, or twice m EV is the potential energy, twice m k. Now k is increased by 16 times. Therefore, if we take it lambda 1, then lambda 2 must be h root under twice m into 16k. If we take 16, that is root under 16 means force, that is 1/4 of h by twice mk. Now what is the value of h by 2 mk? Lambda 1, that is lambda 1 by 4. Lambda 2 equal to lambda 1 by 4. Therefore, change in percentage. What is the change in percentage? Change in percentage is percentage change in wavelength equal to lambda 1, okay, this is 0.25 lambda 1, okay, 0.25 lambda 1. So, this is lambda 1 minus lambda 2 by lambda 1 into 100%. Percentage change means change in wavelength by initial wavelength into 100. That is lambda 1 minus lambda 2, lambda 1 minus lambda 2, that is lambda 1 minus 0.25 lambda 1 by lambda 1 into 100. So, we can get it as 75%. So, in today's topic, we learn so many things and numericals, some valuable questions, etc. अगर आपको और भी कुछ जानना है और भी कुछ कोई क्वेश्चन में डाउट है तो प्लीज़ कमेंट मी or mail me. My mail, official mail is pushparanjan2012@gmail.com. Okay, and subscribe my channel. Next day we will go with the chapter atomic physics, that is the atom, the structure of atom, Rydberg constant, and different series of hydrogen spectra, Rutherford model. Okay, so keep study, have a good result, all the best for your future exams. Thank you.